Good morning, everyone. Oh, good morning if you're in Europe or in the UK. We've got a very international call this morning. We've got Lachlan in New Zealand. Emily and Jennifer have been in New Zealand and are on their way back to Canada just now because they've been building a WikiHouse over there. And we have got Josue and Robinson all the way from Colombia, also joining for this call. You can see familiar faces of Gabri, Clayton, and Amber as well, who are from the WikiHouse team. So we're all here to hear about these two projects. So I'm just going to hand over to Josue and Robinson now.
Bueno, muy buenos días para todos. Es un gusto tener la oportunidad de compartir con ustedes en esta mañana.
So good morning to everyone. It's very enjoy to share with you in this morning.
Con mi familia tenemos una pequeña empresa ubicada cerca de la ciudad de Bogotá, aquí en Colombia, Sudamérica.
We have a little company, a family company actually, near to Bogotá.
Desde hace alrededor de 20 años, nuestra empresa ha trabajado con el reciclaje de plástico de la industria de la zona.
For about 20 years, we have worked with the plastic waste of the local companies.
Hace alrededor de 8 años adquirimos una máquina con la cual podemos fabricar unos tableros plásticos.
So 8 years ago, we got a specialized machine to manufacture some plastic boards with recycled plastic.
Y empezamos a trabajar en el tema del reciclaje y la economía circular.
And we start working in the
Reciclaje y economía circular.
With the recycling and circular economy.
Y como pueden observar, básicamente lo que hacemos es trabajar con el reciclaje de envases plásticos.
So basically what we do is we work with recycled plastic, as you can see in the image.
Les damos proceso y fabricamos los tableros plásticos.
We take these raw materials into different process and then we get the boards of recycled plastic.
Como observan en la presentación, allí tenemos el envase, la materia prima y el producto final que inicialmente decidimos fabricar.
Okay, so as you can see in this slide, all starts with a plastic waste, and then we work with plastic pellets, or with plastic flakes too, and then we manufacture the plastic board, and with this plastic board we can build whatever you want. This is an example. This is a piece of furniture, and here are the pieces of this piece of furniture. Yes.
Aquí observamos parte del proceso, ubicamos el material en un molde.
So here you can see briefly how we made the plastic boards. First of all, we place the material, and also you can play with the textures and colors.
Y finalmente obtenemos un tablero plástico.
And then we melt the plastic and then press it with the machine, and then we have our plastic board. This is the basic explanation of how we make the plastic boards. This is another reference, yes.
Aquí tenemos una muestra de lo primero que fabricamos con módulos de metal y nuestros tableros plásticos.
So this is one example of our work exploring the properties of the material and what we can do with the plastic boards. We use these frames to build a house.
Y inicialmente fabricamos un contenedor.
So as you can see in the image, initially we designed this container. It's detachable design. All the frames that you see in black, they are steel, and the other ones are the plastic boards.
Hacia el año 2020 adquirimos una máquina CNC.
So in 2020, we bought the CNC machine, and yeah, as you can see, we start working with it.
Y empezamos a cortar los tableros plásticos y buscando diseños que encontramos disponibles en Internet.
So we started cutting different designs in the CNC, and we found different designs on the web.
Encontramos disponible este modelo de construcción liviana de casas para emergencia.
In this search, we find this open source design of an emergency house, if I can say that.
Yeah. Sí. Y como es algo nuevo, era algo nuevo para nosotros, empezamos a probar los diferentes materiales plásticos que tenemos disponibles en nuestros tableros.
So because of this is really new actually for us too. We haven't seen this in other country, or so we need to start to explore the properties of the materials that we have available, and this is the result that we have.
Y también cuando se hizo el lanzamiento de Skylark y tuvimos acceso a los primeros modelos, cortamos una pared de Skylark.
So when the Skylark launching started, we have and we get the blueprints available. We cut the first Skylark wall, and this is the result.
Después de las pruebas que hemos adelantado, también construimos otro módulo más grande de vivienda de emergencia para probar los materiales plásticos que tenemos disponibles.
So we also have been working with different constructive systems. This is one example that we are testing right now with different materials. To be specifically, we built this constructive system with HDPE plastic.
Sí, encontramos que el mejor material para lo que estamos necesitando es el polietileno de alta densidad por la rigidez necesaria para las piezas.
Yeah, what he was saying was that we found this definitely we decide to use HDPE as our material because of its characteristics. They are very, very, very good. The behavior of the material is actually really good in the structural. Yes. So that's everything from us. Thank you so much for giving us this space. Sorry for the English; it's not perfect, but we try to explain what we are. This is a briefly explanation of a great amount of work.
Sí. Y por último, estamos muy emocionados porque tenemos programado para el segundo semestre de este año iniciar con la construcción del primer modelo de WikiHouse utilizando nuestros tableros plásticos.
And finally, we're very happy to announce you that for this second term of the year, this semester, we're going to build our first WikiHouse model with 100% recycled plastic. So we want you to know this.
That's brilliant. Thank you so much, guys. Gracias, Robinson. Gracias, Josue. I have some questions. I don't know if you guys have got any. So feel free to jump in when you want. But if I can just start, what are you planning to build? What's your plan for? You said you're going to use Skylark later this year. What would you like to start with? What will be the first thing you build?
¿Qué pensamos construir? Que dijimos que Skylar, pero ¿cuál sería la primera cosa que construimos?
Queremos iniciar con un modelo pequeño. Estamos pensando en el modelo 200.
So we want to start with something small. We're thinking on
Modelo 200.
The 200 reference. I'm not really sure about, but he knows everything.
Yeah, I think he means it's Skylar 200 that he's going to be using for cutting. So what has been the most enjoyable thing so far in all your experiments? Is my question for Robinson.
Chévere de toda la experiencia.
Nosotros conocimos hace alrededor de 3 años todo lo relacionado con WikiHouse. Nos causó mucha emoción encontrar disponible la posibilidad de tener este tipo de modelo de construcción y que lo podíamos...
So we found the WikiHouse community 3 years ago, and it was very enjoyable to found this community and know that you can build that kind of things with different systems, and that makes us happy.
Y aunque está pensado para ser utilizado con tableros de madera, vimos la posibilidad de utilizar nuestros tableros de plástico reciclado.
And we know that the Skylark design maybe, for instance, is designed for to be built with wood, plywood, or the wood that you use, but we think that maybe we can experiment with our plastic boards and have a new result. And yeah.
Y hemos visto la evolución que ha realizado el equipo de WikiHouse.
And we have seen the evolution that the WikiHouse team have done.
Y hemos podido aprender de la mano de la comunidad.
And we have learned very much with the community too.
Todas las herramientas que están disponibles permiten aprender muy fácil.
All the tools that you have available with the community makes us very easy to learn.
Y pues ya tomamos la decisión de empezar y estamos muy emocionados por poder construir el primer modelo.
So we just make the decision to start with the first model.
Si tienes alguna otra pregunta, Mel.
So if you have any question.
Has anybody got any other questions they can ask now? Or we can ask them later as well, but if anybody wants to jump in now. Okay, well, yeah, we've got Jennifer and Lachlan. Yes, go on, Jennifer.
Jennifer, you go first.
I was just wondering how long it takes you to actually make to start to make the plastic process, and like how quickly, like how much raw materials, kind of like how quickly you can turn that around as material to have like on site and access to.
Wait a second.
Bueno, la materia prima la conseguimos en la zona donde estamos ubicados.
So we work with the local industry. So we have the material in the zone, the plastic material, yes,
Sí.
the recycled plastic.
Y la fabricación de los tableros se toma alrededor de 2 horas.
And the average time of manufacturing from the boards, it's like 2 hours.
Más 1 hora de corte por tablero.
And in the CNC machine, you can spend 1 hour.
Y el tiempo normal que necesitaríamos para armar cada módulo.
And we don't have the specific time but maybe you can spend, ¿pero cuánto te podrías demorar?
30 minutos.
Maybe you can spend 30 minutes building the Skylab model.
Bien.
Lachlan, have you got a question? Thank you.
I think that answered most of my questions. It looks very similar to the system that I saw online called Precious Plastics, the recycling and turning into sheets. And I was just curious if you guys have worked with them before or if you've seen them online.
Están preguntando por Precious Plastics, que les parece como un modelo parecido y que si alguna vez hemos trabajado con ellos.
Tenemos conocimiento de Precious Plastic. No hemos trabajado aún con ellos.
Bueno.
Nuestro tema es un poco industrial.
Sí, sí. La organización parece muy pequeño, el plástico precioso, y es como un artesanal, algo así.
Sí, nuestros tableros tienen una medida similar a los tableros de OSB.
Sí. Bueno, sí.
So I'm going to say what they were saying. My father just said that we are aware of Precious Plastic. We know their work and all the community that they have. They have a big community actually. Our plastic boards, the dimensions are similar to the OBS wood. Yes.
OSB is correct, yeah.
Okay.
Yeah. Tenemos algunas preguntas que queremos efectuar a los expertos.
So we have some questions to do to you. To
Yeah,
the
go ahead.
experts.
Go ahead, yeah.
Sabemos que el modelo de WikiHouse ha sido pensado para fabricar los módulos con madera.
So we know that the Skylark design was designed to be built with the wood panels.
Y queremos saber qué opinión tienen de que vayamos a fabricar con módulos plásticos, con tableros plásticos.
Yeah, so we want to know your thoughts or your opinion about what we just tell about that we are going to use these plastic boards to build the Skylark model.
Who wants to go ahead? Who wants to go first?
I can answer very generally, but I think Gabriel would be interesting to know from a structural perspective. Obviously, need to know a bit more about the property of the material. But firstly, just want to say that I think the boards look beautiful, and it's a really nice quality. I really like some of the furniture you made too. But yes, I think in terms of doing small scale structures, small spans, then I think it should work quite well. It seems like it's quite strong without having tested it myself. But I think for small spans, especially maybe up to 3 meters or so, Gabriel, you can comment. It looks like it should be quite suitable for that sort of scale.
Maybe I can jump in briefly. I think that's a very cool project. That's really interesting what you guys are doing. As Clayton was saying, it might depend a little bit on the properties of the material. But one question I wanted to ask you: what thickness of the panels are you making?
Podemos fabricar diferentes espesores, pero la prueba la vamos a realizar con el espesor que sugiere WikiHouse.
So we have different thickness, but we are going to work with the Skylark thickness. ¿Cuál es la medida?
18 o 19 milímetros.
So he's talking about 18 millimeters.
Or 19, yeah. Because I was thinking if you find out that your structure is not stiff enough, you can always increase the thickness, and you can find an optimal solution to adapt to WikiHouse to plastic materials.
Sí, entonces está hablando de que sería bueno aumentar el espesor del material para poder tener como los mejores resultados con el modelo.
Ok, perfecto. Muchas gracias por la sugerencia. ¿Tienen alguna sugerencia adicional que quieran que nosotros probemos o tengamos en cuenta?
So he's asking if you have any other technical suggest.
I have two thoughts myself, which I'm just going to throw into the ring. So if you're using a kind of a solid plastic composite product like that for the blocks, if you stuffed the blocks with insulation, I'm wondering then if the moisture in the insulation will be trapped inside the blocks. So that's one question I have about whether then you'd need to perhaps modify the block design to allow some of that moisture to dissipate out of the insulation and out of the blocks. There might be something in there. And then another kind of thought just to throw into the ring is I think the material is really beautiful and exciting, and it's something that people want to see. So it's two things, isn't it? It's using it as potentially as a structural material, which is tucked inside the construction of a building, but then there's also the opportunity to use it as a material that you can see that's exposed. And I think for maybe both options, there's a question around the perhaps the fire performance of that material. I think that's something we're thinking about a lot in the UK now.
Gracias por tu pregunta. Hemos realizado pruebas con módulos que hemos tenido expuestos al ambiente.
So we have done different experiments with the material to test the properties and how the material behaves in the environment.
Por eso encontramos que el mejor material, el que se comporta mejor, es el polietileno de alta densidad.
And we found that the best material definitely is the high density polymer.
Lo único que vemos es que los rayos UV afectan el color del material.
The only thing that we see is that the UV rays affect the color of the plastic material.
Pero no hay un cambio adicional en la rigidez o en el tablero plástico se mantiene.
But we haven't seen like strong changes in the material. So the properties maintain very good.
Básicamente es lo que hemos observado. Por supuesto, queremos hacer contacto con universidades para que nos den soporte y nos ayuden con pruebas de laboratorio.
So that's basically what we have seen to this point, that we want to contact with universities too, in order to make different technical proofs.
Okay.
Thank you so much.
I have a follow-up question.
Oh yeah, go ahead. Yeah.
If you went ahead with this project, is there any reason you couldn't just press the right shapes without having to cut it again afterwards? So make a mold the shape of the WikiHouse block and then just press that?
Que si nos queremos meter con un proyecto, que no habría una forma de simplemente sacar las piezas ya fabricadas, o sea, como con moldes.
Bueno, con la maquinaria que tenemos disponible realmente no es posible.
So with the machinery that we have available today, it isn't possible.
Se puede explorar con otro tipo de maquinaria para poder lograr estas piezas ya listas para ensamblar.
So we can explore another machines to make this happen, but yeah.
Okay.
Thank you. Thanks so much. I'm gonna shortly be handing over to the guys from New Zealand who have been patiently waiting to tell us about the project. But just two things from me. One is the community, as you said, is full of really helpful, really nice people actually who are happy to help you, as well as us, are happy to help you. If you ever want to post anything, you can post it in Spanish as well. So if you've got any questions, anything you want to share, we would love to see progress, any photos. Please use that as a forum, and you obviously have my contact details if there's anything else. Again, thank you so much for joining us. I know it's really late or really early in the morning for you. I'm going to hand over to Lachlan, Emily, and Jennifer, who, as I said, they are in New Zealand, and Emily and Jennifer are from Canada, actually, and they are just on their way back after helping Lachlan with his WikiHouse Skylark 200, is that right, project. So I'll hand over to you guys.
Hi, I'm Emily, and I'm here with Jennifer and Lachlan. And so maybe just starting off by telling you a bit about how we met and started working together. So Jennifer and I live in Canada, and we met during architecture school and have since started our own business doing architectural and furniture design. And I met Lachlan 11 years ago in New Zealand while I was on exchange during university as well. And so we've just stayed in touch ever since, and have always had a shared interest in housing and making cool stuff. So Lachlan's background is in software. He was a startup co-founder and CTO, and has turned to the urban planning and housing world, and recently moved back to New Zealand after living in Singapore, and decided to decided to try building some wiki houses together. So we're bringing together our sort of shared experiences to start a company, which is called New Neighbor, and it'll be prefab housing, aiming to bring, you know, well-designed, affordable, and high quality housing to New Zealand.
So I have a family shed. My dad used to make trailers for his entire life. It's at least 40 years old. The concrete's in horrible condition, but it is ours to use and free, and has most of what we need. We had to upgrade the electricity. Am I muted? No, we're good. So we've cleared it out. This is Josh. He's been helping with everything. So this is how it started after we'd done a bunch of cleaning and Emily and Jen hadn't arrived yet. And we slowly, I seem to have jumped quite a bit there. No, there we go. We jumped a ton of time. This is our first WikiHouse pieces that we've cut. These are for an end wall, I think. This is it on our blue elephant. We have one of these as well, Josue. We've had a bunch of issues with that, but Emily will go over that later. Here's our current redesign. So we've added a bunch of shelving on the side, and then our own sort of workspace using some of the tables that Melchior designed. He helped a lot with us getting the blue elephant machine and getting set up. And this is the start of us building an end wall. I think there's a few more, with the top of the end wall being just below the light behind it, so we couldn't actually attach a roof inside the shed. So we've had to deconstruct it since then, but it was a good test of everything we did so far. I'll jump off to let Emily or Jen speak.
Okay. Hi, can you guys hear me? Okay, great. So the photos Lachlan showed, everything we kind of started with nothing, and we've been building it from the ground up. So definitely has been some of the challenges is just like learning the new software of how to actually use the CNC machine, and learning the fusion that goes with it. So that's been really fun and rewarding when everything goes well and everything comes out cut correctly. Less so when things, when the bit accidentally gets like dragged through instead of lifted. We've had a few of those incidences, so that's been a lot of fun. But as Lachlan was showing, we are planning on building a single-story, one-bedroom. It's about 57 square meter house, and so we're going to build that on the property here in New Zealand. And then we're working towards that being the basis of the prototyping for developing a range of standard models that would be ranging from studio to 3-bedroom, and including some 2-story units eventually as well. So we're kind of looking at this from the framework of designing sort of prefabricated standalone units, but also ones that could possibly be like deconstructed and expanded, or having additional units on the same site and connecting them, whether through actual covered space or enclosed space, and kind of just letting the product grow with the user. And again, trying to meet that ground of like providing affordable housing for people when it's just not available in New Zealand whatsoever. So we mentioned we're using the Skylark 200 system, and it has been going really well, and we've been having a lot of fun with it. But But I think the biggest challenge we've been having is kind of the inconsistencies of our plywood thickness. And working in Canada, even though we do use metric, we do everything imperial. So having the kind of like bouncing back and forth between dimensions has been really fun, and a lot of calculators recalculating things. But yeah, it would be really nice with the WikiHouse kind of going forward if there was an ability to create parameters within the blocks to adjust for the ply thickness, because that is one thing that we've kind of have had challenges with, just trying to find a consistent thickness of ply here. Yeah, and then what we've been just enjoying for the last 2 months has been really fun, just how quickly it is. You get to see the work happen right in front of you in a day. I think we put up the end wall, like we cut it in an afternoon and then assembled it the next morning, and it was like, oh, that's done. Great. And it's pretty fun. Like, as architects, we don't often get to see our designs. The start and end process are, typically at the start and the end. Whereas like right now, it's been fun, like testing it and like cutting out a portion and then building it right away. And you get to just have that immediate sort of reward of how the pieces go together and start to see instantly how the design can be improved. I think we've done a lot of, we've realized a lot through this process of just even the scale of it and other sort of ambitions that we have with our next design. So yeah, I guess like going forward, I think the one thing that now that we have started putting it together and having to start to think about the builders and other trades on site, we've been kind of trying to wrap our heads around like how it actually all comes together in the 3D and like how all the plumbing and electrical and structural and airtightness elements are all coming together, and how they work within the system of like the assembly and the order of assembly and all those things. So that would be something that we would love to get more support on from WikiHouse. But yeah, I think probably went a little fast, but I think I covered most of it. Emily, Lachlan, anything you guys want to add?
Yeah, I'll add a few things.
Go ahead,
So
Lachlan.
Emily, go first. No, mine will be
Okay,
a long
I was
way.
just
You go.
gonna circle back to the plywood thickness issue, in that we spent a lot of time like adjusting the tolerances and got everything working really well, but then sort of discovered a challenge when we started building the end wall, in that if the length of the floor is 4.8 meters, and each block making up the end wall is supposed to be 600 millimeters, but it's actually 601 millimeters. So by the time you get to the end of the end walls, the whole thing is out by about 5 millimeters, which then the bow ties won't fit in. So it was kind of one of those things that we were like, we had spent so much time trying to like work around that challenge of having slightly thicker plywood, but we sort of kind of hit a roadblock in that regard. We found some ways to make it work, like planing the piece of wood down on a thicknesser to make it slightly thinner. But yeah, I think just to give a little bit more explanation as to what that challenge was, and if anyone had any thoughts or like suggestions of how to, any ways to work around that.
Yeah, that's a very good point, and it's something that we've even found with building to standard 80 mil thicknesses, what we call standard. If your tolerance is slightly out, if the parts aren't sort of compressed together when you build the blocks up, then you get that cascading effect. So one of the things is to reduce the 600 mil width of those blocks to like by 1 millimeter or by 2 millimeters in the design, so that you might get some sort of hairline gaps between them, but actually that gives you a lot of flexibility, and then potentially sort of makes it, sort of proofs it for other thicknesses as well. And that would probably be the easiest thing. In terms of a have a sort of parametric thing you can tweak to change the thicknesses. We're probably a way away from that. It kind of has to go all the way down, right to the very beginning kernel of the geometry, and then has to work all the way back when we do new releases and release cycles. So at the moment we don't have, like, it's not encoded in that way, but it is something we can think about in the future. If this is going to be, like, a common challenge, but my first thought would be to try and do it through tolerances and just have plenty of extra play, because that extra play actually, when the structure is built, doesn't make any much difference, whether it's a millimeter or 2 millimeters. If there's, rather make it smaller than too big, is kind of the philosophy. But yeah, we're keen to explore that with you, and also just really excited to see your progress and follow the project as it develops.
Thanks. Yeah, that
What-
that makes a lot of sense.
Sorry.
Sort of adjusting the block to be slightly narrower. It's something that we talked about, but then we're like, we don't want to go down that road if it's not going to be the right solution. So hearing that having a little bit of extra wiggle room is actually a good thing is great.
I was just interested to know, in terms of what is the material source, what's the environment like in terms of the cost and the material, like where's it coming from there? Like, is it a big problem? Like,
So this plywood is 18 mil, which is impossible to find in New Zealand because we do 19 by 2400 by 1200, which caused other issues. But so we had to get Chilean ply from this company called IBS, and the thickness is supposed to be between 18 and 18.4. But because New Zealand has a quite weird wood treatment requirement that we're hoping to, like, sidestep by sheathing the house in something else, it can get up to like 19.4. Like, it's like a huge difference. And they're like, yeah, just measure each ply. And I'm like, well, we put on 30 at a time. I don't really want to have to, like, manually, like, use a caliper to check the thickness. But yeah, so it's Chilean ply. I think it's pretty good when it's not treated, but the treatment, which I think is banned in the UK, it's called CCA, it's got arsenic in it, is water-based, so it causes quite a significant deviation in dimensional stability, but mostly only in the vertical thickness. So we found that horizontally, or like length and width was fine. We're hoping that we can either switch to LOSP treatment, which is only one stage lower, but it's a solvent, so it shouldn't change the thickness, or entirely untreated, and then we can just wrap the house in 9 mil treated OSB, which I think ends up the same price or cheaper, because the untreated ply is cheaper than treated ply, and you end up getting, like, rigid sheathing, which is great for the bracing of the house. So we're waiting on our New Zealand architect, because while these two are architects, they can't actually sign up anything here to verify that statement. But yeah, the company we're working with, Bunnings, is like a really large supplier of wood in New Zealand, and they're happy to take it back if it's not right. Our contact's just off work for like 2 weeks. New Zealand's very laid back. They don't have, like, secondary contacts with businesses. They're like, yeah, just wait 2 weeks. I'm like, okay, that's thousands of dollars a time, but sure. But yeah, some of our solutions have been to just double up blocks. So if there's an end block, if we do 2 of them, it forces the tightness to be locked with inside the 1200 mil width. So the middle 2 are quite hard to fit in, but once they're in, they're like exactly what we wanted them to be. And our solution was to go to the local men's shed, which is very sexist. It's a bunch of old dudes with some power tools, and they did the thickness thing for us down to 18 mil. But yeah, grateful for them.
yeah, it's fascinating. I guess the other, if it become for you as it goes back to the thing you were saying about Dreamland as a parametric thing, right, where you could just go whoop. But I guess the other thing is, if that's a consistent permanent thing where you go, right, you know what, it's actually worth us investing in the time to generate our own bespoke set of Skylark blocks, which are designed for being a different thickness from the outset, even though that's going to be super annoying. But at least in theory, you know, if you did it.
Would the treatment thing still be an issue if you're using the New Zealand supplied 19 millimeters? Because presumably, from memory, that's untreated, right? It's not CCA. you'd still be required to treat it unless you do some
I'm really
manual
hoping we
sheathing.
don't need to. I
Right.
don't think the treatment's because of the region. I just think that the structural engineer we spoke to was like, I think this is what's required because of how the wood's used. Because it's technically sheathing instead of framing timber, because in New Zealand framing timber is treated, but it isn't treated to this level. So I'm wondering if there's some way we can resolve what the government needs without necessarily having to do what the current solution is, because the current solution is awful. Like cutting that wood and having it in the air is super bad for your lungs, and we really don't have a way to dispose of the sawdust either. So the untreated ply we can just sweep up and take to the compost essentially. But this stuff is it's almost toxic. I think it is toxic. We can't.
Yeah, I was going to say,
like
you must have to wash your hands all the time, otherwise, like a day at work will turn into an Agatha Christie novel.
Yeah, you're you got to undress outside the house. We weren't allowed to come in with the dust on us. But yeah, hopefully we can resolve that. We're just waiting on the New Zealand architect, who's been lovely, but also I think busy with other stuff.
And what about OSB as a material all around? What's the supply like? Is that an option?
I couldn't find much of it. It should technically be cheaper, but I also couldn't find the structural properties anywhere. Like no one had a spec sheet saying whether it was equivalent to ply. I'd happily use anything. My goal is essentially to stick as close to the Skylight system as possible, so we don't have to do any of that work ourselves, and hopefully we can upstream some things. So the Chilean ply was the option to start with, so we can stick with 18 mil. But we could go to 19 mil and change it in future if that became something useful. Or we just have a permanent thicknesser. We just cut 1 mil off every sheet of ply, something stupid like that. But yeah, I couldn't find any OSB. The only OSB that I saw in use was done by Charleston Fab Lab in the US, and that's like a slight variant. Like it's not actually OSB, it's like some other brand, and they've got a custom process.
Yeah, we've found, haven't we, Clayton, that the OSB and OSB, there's a lot of variance. So we're quite fortunate here in the sense that both Scottish and Irish plants have recently up-spec'd their machines. So the OSB they're producing here is really much more regular and predictable and precisely 18 millimeters, whereas a few years ago that was not the case. I remember when we were trying to first experiment with it in 2014, 2015, and yeah, like in theory it was 18, but in practice you were getting up to 19.1, even at the lumpiest bits, so yeah, it matters a lot, doesn't it?
Yeah, it's surprising how much 0.3 mil can stack up to become, oh, it doesn't work at all.
I have a question for you guys in New Zealand. So the idea is to start a company, you said at the beginning. So this first house, what happens after that?
So in August last year, New Zealand rezoned essentially every house in every town to be allowed to have, I think, 2 other dwellings up to 3 floors on the same lot if you got over a certain amount of square meters. And I don't think you need to subdivide, but the building size we're hoping to fit should just allow anyone to just put one in their backyard. So the story we're telling is that because WikiHouse is customizable, you help your kids buy the first house, they put it in the backyard. When they can afford their own land, they take that house to that land. When they have a partner, they add some space. When they add a child, they add a floor. I think editing a WikiHouse is probably harder than just like replacing it wholesale. And if we actually believe in the product, we could probably just like take back the one we sold, zhuzh it up and resell it on, and then like they get a fresh 2-story version, depending on like what the cost of renovation would be. But yeah, the intention is that like the way we used to build houses, which is you add a room with every child, is perfect for the New Zealand environment where we just genuinely can't afford houses anywhere. So this town I'm currently in has 100,000 people. The average house is $1 million. Like the salary to house price is at 12. Like it's just literally impossible to own a house in this country unless you have a friend that has a backyard or like are a lawyer or a doctor. Like it's insane how distorted it is. So we're hoping that we can just crash that market by providing relatively low cost housing. Our goal is to undercut the cost per square meter by 40%, I think, as the envelope of the house. And because it's a WikiHouse, it's going to be of a higher quality than New Zealand. Like our houses are 10 to 12 centimeter thick walls, like just terrible construction quality. Like my parents' house feels quite nice, so it looks quite nice. Freezing, absolutely freezing. These are Canadians. They live in -30, and they're like, your house is too cold. Just because we don't build it properly. So hopefully, yeah, we can build a good product that we can then help a lot of people get into. And ideally, I'll be looking at some of the other OOSL systems. I believe there's one about land ownership that I really want to do. There's this plot of land down south that's like 600 square meters from the town center that I could fit 75 houses on. And I kind of want to just get the cost of the land per house to about $10,000, whereas it's currently like 500. So if we can get that very, very low, or even just like remove it from the conversation, then you can reduce the cost of housing to 200,000 instead of $1 million. That's the 5-year goal.
And I can totally see, Emily, the thing you were talking about again, the way that sets you a really interesting architectural brief in terms of then the fit out and everything, right? Which is, especially if they're designed, these buildings are designed for that kind of pop up, you know, want to be safe, want to be lovely, but then potentially designed for disassembly as well. Like it's going to be a really kind of beautiful but interesting brief to how do you do that? Like, yeah, we'll definitely be interested in sort of learning from what you're doing, but also helping out if we can or whatever, and all of that stuff.
It's been great to get involved in the community too and see what other people around the world are doing. Really inspiring. So thanks for creating such a great community.
And thank you guys for spending the time telling us about the project. Please keep asking questions, like no matter how obscure they are, we love answering them via the community. And obviously everybody else can learn from you as well. I just noticed that we are coming to an hour, so I don't want to keep you. I know you guys in Colombia need to go to bed as well. So yeah, just big thank you from us. You've got our contact details, you've got the community, please reach out if there's any other ways we can help. And again, thank you so much for joining us. Lovely to see you. Really lovely to just see how big and broad the community is.
Yeah, and we're really rooting for you.
Yes.
Thanks,
Thank you very much.
Yeah.
I'm going to stop recording now. Thank you.
Thank you, everyone.
See you later.